Okay, in this video, we want to extend the idea that we saw with the nearpoint function and learn a new function called Minpos that mainly works with position on a surface. So what is the problem here? So we've seen something that is cool. We can actually use the nearpoint in combination with point to steal attributes from the closest point on an object. But what if I don't want to work with any attribute, but with one specific attribute, and that is position? So let's say we want to change the position by reading out the position of the near point. And if I run this, you can see actually kind of like this. You can see that my points will jump to the position of the closest points, and then we get this faceted version of the grid. And if I move the grid, you can see that it kind of creates, it always fills the faces because the point will always find the closest point on the second input. This is fine and cool, and it's actually great that this works, but it has a pretty serious limitation, and that is it will only find the closest point. When I do something like this, of course, I will kind of remember a node that does that already for us, and that is the ray node. But if I try this with a ray node and use the minimum distance, then it looks like this. And currently, by the way, it transfers the color, so let's get rid of that. And what we can see is that the difference is that the points on the grid don't find the closest point on the sphere, but they actually find the closest position on the surface of the sphere. So it's not all about the points, it's about the surface as a whole, which means that some points kind of find a position in the middle of a primitive. Now, how can we do this in Vex? Well, we can't do it with point and near point because, as the name suggests, they only work with points, but we need something better. And for this, we use the Minpos function. And the Minpos function is very easy to understand because it only has two inputs, the geometry and the vector input. Let's open the help again. And here again, we have point as an input, and it sounds a little bit like it needs a point number, but careful again. When we look at the data type, we can see this is actually a vector, so probably a position in space. And it returns the position of the closest point in the given geometry to the point. So in other words, it gives back another vector. So this is important. Minpos, as the name suggests, doesn't work with points. It works purely with positions. So a position is the input and the position is an output. And it finds the closest position on the surface of a particular geometry. So let's try that. It's not that hard to use. So we want to find the closest position and bring this into my current position. So in other words, you want to move each point of the grid to move to the closest position on the surface of this sphere. And for this, we need, of course, read out the second input and then relative to what? To my current position again. So you can see, pretty simple. Let's try this, Control Enter. And as you can see, it's not close to the result of the ray. It's exactly the same result as the ray node. The only difference here is the normals. So if we ignore this for a second, you can see that the result is almost identical other than the guide geometry. So here you can see no difference between the two. Let's quickly use a switch for this. There you go. No difference. Exactly the same result. So once again, we were able to rebuild a node ourselves. With the Minpos function, we were able to rebuild the ray node. So again, what can we do with this? The same as we did with all the other examples. We just control this with a mask. Paint an attribute, because again, that's something the ray node isn't capable of doing. You can't put in any kind of attribute that controls the strength of the whole thing. Yes, you have a scale here, but this scale is global. There's no way to use a particular attribute to control the strength of the ray node. So this is where our own version of this allows for more than the in-house functions that come from side effects. So let's do something like this. And now we say we only do this if, once again, our mask attribute is higher than 0.5. Then only then it will be triggered. And this then looks like this, that we have a ray node that we can turn on and off for particular points. Now, of course, right now you're interested in being able to use this not just with an if as an on-off, but controlled by distance. But for that, we still need a bit more functions, but don't worry, we will do a version of this once we learn how to calculate the distance between the points, because then we can do a very funky version of the ray node with way more functionality. But so far, all we want to understand is that we have the Minpos function, which is really powerful because it finds the closest point on the surface of a second object. And that's also, of course, true when I increase the resolution, because then you can see it even better. And when we combine this with more functions, we have a pretty powerful tool. And just like that, we were already able to rebuild the ray node and combine it with a simple mask on and off function as well. So that's the Minpos function. We will use this for more interesting things soon. So I hope this is helpful. Thanks very much and see you later. Cheers.